For every human who has ever lived, it has been there, a silent, steadfast guardian in the night sky. It is the metronome of our oceans, the keeper of our calendars, the lantern for nocturnal wanderers. It is a world of silent gray deserts and magnificent desolation, a constant and comforting presence that has watched over the earth for more than 4 billion years. We are tethered to it by an invisible thread of gravity, a bond that has shaped our planet's past and secured its future. But what if that thread were to be cut? What if, in a single inexplicable moment, our celestial companion were to simply vanish? It is a thought experiment that uncovers a profound and startling truth. The moon is not merely a decorative ornament in our sky. It is a fundamental pillar of our world's stability. Tonight, we journey into a hypothetical world, an Earth without its moon. We will watch the oceans calm, the nights plunge into darkness, and the very rhythm of our planet begin to change. Prepare yourselves for a voyage into a familiar world made strange as we uncover the epic story of what would happen if the moon disappeared. The event itself would be perfectly silent. There would be no cosmic boom, no celestial fanfare. One moment, the moon is there, a familiar, pockmarked face in the cosmos. The next, the space it occupied is filled only with the cold, distant light of the stars. For half the world, the disappearance would go unnoticed until nightfall. But for the other half, those bathed in its gentle, silvery light, the effect would be immediate and profound. The light would simply switch off. The moon, of course, has no light of its own. It is a colossal spherical mirror, 2,159 miles in diameter, reflecting the light of a star. It is an imperfect mirror, its dark, dusty surface reflecting only about 12% of the sunlight that strikes it. Yet, this is enough to make it the brightest object in our night sky, a beacon that can outshine all other celestial bodies combined. A full moon can be up to 2,000 times brighter than the next brightest object, the planet Venus. This moonlight is the engine of the nocturnal world. On the night of the vanishing, this engine would stall. The world would be plunged into a darkness it has not known for billions of years. The analogy is a wanderer in a dense forest who has navigated their entire life by the light of a single distant lighthouse. When that light goes out, the forest becomes an unfamiliar, disorienting, and treacherous place. Humanity, with its artificial lights, would be insulated from the worst of this darkness. But the animal kingdom would not. Nocturnal predators that rely on moonlight to hunt, like owls and lions, would find their world suddenly and completely blind. Their prey, in turn, would be shrouded in a new life-saving darkness. The ancient evolutionary dance of hunter and hunted, a dance choreographed by the phases of the moon, would be thrown into chaos. Ocean life would be equally affected. The Great Vertical Migration, the largest migration on our planet, happens every single day. Trillions of tiny zooplankton and the creatures that feed on them rise from the deep, dark ocean to the surface at night, to feed and descend back into the darkness at dawn to hide. This migration is timed with the setting and rising of the sun, but it is moderated by the light of the moon. Without the moon's faint light, this ancient rhythm would be disrupted, with unknown consequences for the entire marine food web, and the sky itself would be transformed. With the moon's glare gone forever, the heavens would open up in a way that most modern humans have never experienced. The Milky Way would cease to be a faint, cloudy band and would become a brilliant, blazing river of light, a celestial structure of breathtaking complexity, dominating the night sky from horizon to horizon. Distant galaxies, like Andromeda, would become easy, naked-eye objects. The universe would feel closer, its scale more apparent, its beauty more overwhelming. The nights would be terrifyingly dark, but the heavens would be a treasure of unimaginable richness. This new profound darkness would be the first and most gentle consequence of the moon's disappearance. But in the oceans, a much more powerful and immediate change was already beginning. The oceans of our world are in a state of perpetual rhythmic motion. They are breathing, a slow, majestic, planetary scale inhale and exhale that we call the tides. This rhythm is the most obvious and powerful connection we have to our moon. It is the physical manifestation of its gravitational embrace. In the moment the moon vanished, this embrace would be broken, and the breath of the oceans would become a shallow whisper. To understand why, we must understand the nature of tidal forces. Gravity gets weaker with distance. The moon's gravity pulls on every part of the Earth, but it pulls hardest on the side of the Earth facing it. and weakest on the side of the Earth facing away from it. This difference in gravitational pull is what creates the tides. The analogy is a giant cosmic hand gently squeezing a rubber ball. The moon's gravity stretches the Earth. The solid rock of the planet stretches only a little, but the liquid water of the oceans is free to move. The water on the side of the Earth nearest the moon is pulled towards it, creating a bulge, a high tide. But crucially, the solid Earth itself is also pulled towards the moon, leaving behind the water on the far side. This creates a second simultaneous bulge on the opposite side of the planet. As the Earth spins beneath these two bulges, we experience the rhythm of two high tides and two low tides each day. But the moon is not the only celestial body pulling on us. The sun, with its immense mass, also exerts a tidal force. However, the sun is 400 times farther away than the moon. Because tidal force depends so heavily on distance, the sun's tidal effect on Earth is only about 46% as strong as the moon's. The sun is a distant secondary partner in this gravitational dance. In the moment the moon disappeared, its dominant tide-shaping force would vanish. The two great tidal bulges it created would relax, and the water of the oceans would slosh and redistribute itself around the planet. This would likely trigger a series of chaotic planet-wide tsunamis as the ocean basins tried to settle into their new gravitationally simpler reality. Once the chaos subsided, the tides would not cease to exist entirely. They would now be governed solely by the weaker, more distant pull of the sun. The new solar tides would be less than half the height of the lunar tides we are used to. A high tide that once rose by 10 feet would now rise by less than 5. The great tidal ranges seen in places like the Bay of Fundy, where the water level can change by over 50 feet, would be reduced to a fraction of their former glory. The daily breath of the oceans would become a faint, shallow sigh. The consequences of this change would be felt most acutely in a fragile, dynamic, and vital region of our planet, the world between the tides. There is a world that is neither land nor sea, but both. A realm that is submerged in water for half the day and exposed to the harsh air for the other half. This is the intertidal zone, the vibrant, rugged shoreline that is dictated by the rhythm of the moon's tides. It is one of the richest and most diverse ecosystems on the planet, and in a world without a moon, it would be the first to die. Life in the intertidal zone is a life of adaptation and opportunity. It is a world of creatures that have evolved to thrive in this constantly changing environment. Mussels, barnacles, and sea stars have learned to cling to rocks to avoid being swept away by the crashing waves. Crabs and snails have developed shells to protect them from drying out during low tide. The tidal pools left behind by the receding water are natural aquariums, teeming with anemones, small fish, and algae, each a miniature, self-contained ecosystem. This entire world is built upon the scale of the lunar tides. The analogy is a bustling vertical city, built on the side of a mountain that is flooded daily. The residents have evolved to live at specific altitudes, their entire lives dependent on the predictable rise and fall of the water. The lunar tides create a vast multi-story city, with different species living in the high tide, mid-tide, and low tide zones. When the moon vanishes, and the tides are cut by more than half, this vertical city shrinks. The high tide zone, the upper floors of our city, would be left high and dry permanently. The creatures that lived there, the barnacles and periwinkles adapted to long periods of air exposure, would be stranded. The mid-tide zone would now become the new high tide zone. The vast, rich ecosystems of the lower tidal zone would now be permanently submerged. The entire structure of the city would collapse. This would trigger a mass extinction event along the coastlines of the entire world. The loss of the mussels and barnacles would mean the loss of food for seabirds and sea stars. The destruction of the tidal flats and estuaries would devastate the nurseries for countless species of fish and crustaceans, sending a shockwave up the entire marine food web. The economic impact on humanity would be immense, as the global fishing and aquaculture industries, which depend on the health of these coastal nurseries, would collapse. Furthermore, many species use the tides for reproduction. Sea turtles ride the high tides to lay their eggs high up on the beach. Tyrrhenian fish time, their spawning events with the highest spring tides, burying their eggs in the sand to be washed out to sea on the next high tide. All of these ancient lunar-timed reproductive cycles would be thrown into disarray, pushing these species towards extinction. The death of the intertidal zone would be a quiet coastal apocalypse, the first great biological casualty of a world without a moon. But the ocean's turmoil was just beginning. The moon's influence on the oceans extends far beyond the daily rise and fall of the shoreline. Its gravitational pull is a colossal, invisible hand that constantly stirs the entire volume of the world's oceans, from the surface to the deepest abyssal plains. This stirring is a vital component of the engine that drives our planet's climate. The loss of the moon would be like removing a critical gear from this complex and delicate machine. The oceans are not a uniform body of water. They are layered, like a cake, with warm, less dense water on top, and cold, dense, nutrient-rich water at the bottom. The daily passage of the tidal bulges across the ocean basins creates a powerful mixing effect. As the tides flow over underwater mountain ranges, ridges, and continental shelves, they generate immense turbulence, creating underwater waves that can be hundreds of feet high. This turbulence is the primary force that dredges up the cold, deep water, mixing it with the warmer surface layers. The analogy is a giant planetary-scale whisk. The moon is the hand that drives this whisk, ensuring the contents of the great bowl of the oceans are constantly, if slowly, being mixed. This mixing is crucial for two reasons. First, it brings vital nutrients, the decayed remains of dead marine organisms that have sunk to the ocean floor, back up to the sunlit surface where they can be used by phytoplankton. These microscopic plants are the base of the entire marine food web. Without the moon's powerful tidal mixing, this nutrient conveyor belt would slow down dramatically, potentially starving the surface oceans and devastating phytoplankton populations. Second, this mixing helps drive the great ocean currents that transport heat around the globe, the thermohaline circulation. This is the great planetary heating and cooling system. Currents like the Gulf Stream bring warm water from the tropics up to the North Atlantic, warming northern Europe and regulating global weather patterns. While these currents are primarily driven by differences in temperature and salinity, the energy supplied by tidal mixing is a crucial and still poorly understood part of the equation. With the moon gone and tidal mixing reduced by more than 2/3, the entire system would be disrupted. Our climate models begin to break down when faced with such a fundamental change, but the consequences would likely be catastrophic. Ocean currents could slow down or shift their paths. This could lead to dramatic and unpredictable changes in global weather. Some regions might experience extreme warming, while others, like Northern Europe, could be plunged into a severe ice age. The complex, interwoven system of our planet's climate, a system we are only just beginning to truly understand, would be thrown into a state of chaos. The full consequences of this change remain a deep mystery, a powerful reminder of the unseen connections that bind our world to its lunar companion. For billions of years, our planet has been slowing down. Its rotation, its daily breath, has been getting progressively longer and slower. In the time of the dinosaurs, a day on Earth was only about 23 hours long. 4 billion years ago, it may have been as short as 6 hours. This gradual slowing is no accident. It is a direct consequence of our relationship with the moon, and if the moon were to disappear, this ancient planetary deceleration would largely cease. The process is called tidal breaking. It is a beautiful and simple consequence of gravity and friction. As we've seen, the moon's gravity creates two tidal bulges on the Earth because the Earth spins faster than the moon orbits it. These bulges are not directly underneath the moon. They are dragged slightly ahead of it by the planet's rotation. This means the bulge of water on the side of the Earth facing the moon is slightly ahead of the moon in its orbit. This bulge has its own mass, and therefore its own gravity. It pulls on the moon, giving it a small gravitational tug forward. This constant tug is like a cosmic gas pedal for the moon, accelerating it slightly, which causes it to slowly spiral outwards into a higher orbit. This is why the moon is getting about 1.5 inches further away from us every year. But every action has an equal and opposite reaction. As the tidal bulge pulls the moon forward, the moon's gravity pulls the bulge backward. The analogy is a child running on a merry-go-round. The child tries to run forward, but their feet are pushing the merry-go-round backward, slowing it down. The tidal bulge is that child, and the Earth is the merry-go-round. The moon's constant backward pull on this bulge creates a friction, a drag, on the entire planet. This is the tidal break. This process has been happening for over 4 billion years. The energy from Earth's spin is being slowly transferred to the moon's orbit. The Earth slows down, and the moon moves further away. If the moon were to vanish, this primary braking system would be removed. The solar tides, which are much weaker, would still exert a tiny braking force, but the rate at which our day is lengthening would drop by more than half. The 24-hour day, which is currently getting longer by about 2 milliseconds every century, would become much more stable. This may not seem like a dramatic consequence, but it would have a profound effect on the deep future of our planet. The long, slow march towards ever longer days and a more distant moon would be over. The geological and biological evolution of our planet, which has been unfolding against the backdrop of this slow rhythmic change, would find itself on a new and unknown timeline. The very breath of the planet, its fundamental rhythm of day and night, would be untethered from its ancient partner, set adrift in cosmic time. But the effect on our planet's rotation was not the most dangerous consequence. A far greater threat was now beginning to emerge, a threat to the very stability of our world. Our planet spins through space with a remarkable degree of stability. It is tilted on its axis by a gentle and consistent 23.5 degrees relative to its orbit around the Sun. This axial tilt is the single most important factor in creating our predictable life-giving seasons. It is the reason we have summer and winter, spring and autumn. This stability feels like a permanent fundamental feature of our world, but it is not. It is a gift, a state of grace granted to us by the constant, powerful gravitational presence of our moon. The moon acts as a celestial anchor, a massive gyroscope that keeps our planet's spin from wobbling uncontrollably. To understand how, we must first understand that the Earth is not a perfect sphere. Because of its rotation, it bulges slightly at the equator. This equatorial bulge is the handle that other celestial bodies can grab onto with their gravity. The Sun and the other planets, especially the massive Jupiter, are constantly tugging on this bulge, trying to pull the Earth's axis upright. This tugging should cause the Earth's axial tilt to change dramatically over time. The analogy is a spinning top. A fast spinning top is stable and upright, but as it slows down, external forces like a gentle breeze or a bump on the table can cause it to wobble dramatically. Its axis of rotation begins to swing around in a wide, chaotic circle. The Earth is that spinning top, and the gravitational pulls of the Sun and Jupiter are the constant disruptive breezes. So why doesn't our planet wobble? The answer is the moon. The moon's gravity also pulls on the Earth's equatorial bulge. And because the moon is so close and so massive, its gravitational influence on the bulge is more powerful than that of all the other planets combined. The moon's pull doesn't stop the Earth from wobbling entirely. Our planet does have a slow 26,000-year wobble called precession, but it acts as a powerful damper. It keeps the wobble constrained to a very small, very stable range. It is the cosmic equivalent of a steadying hand, preventing the spinning top from ever tipping over. It is a powerful anchor in a chaotic gravitational sea. If the moon were to vanish, this anchor would be gone. The Earth would be left to the mercy of the much weaker, but still significant, gravitational pulls of the Sun and Jupiter. Over long periods of time, millions of years, the results would be catastrophic. Without the moon's steadying influence, Earth's axial tilt would begin to vary chaotically. Our planet would begin to tumble. Scientists have run simulations on what this would look like. Earth's obliquity, its axial tilt, could swing wildly from as low as 0 degrees, where there would be no seasons at all, to as high as 45 degrees or more. Mars, which lacks a large moon to stabilize it, is a real-world example of this. Its axial tilt is believed to have varied chaotically over its history, which may have contributed to its dramatic climate change. An Earth without a moon would be destined for the same fate, and the consequences of this cosmic tumbling would be an end to the world as we know it. With the moon gone, and the Earth's axis now untethered, our planet would embark on a long, slow journey into climatic chaos. The predictable, life-sustaining rhythm of the seasons, a rhythm that has allowed complex life to evolve and thrive for hundreds of millions of years, would be replaced by a terrifying and unpredictable lottery of extreme weather. Let us travel forward in time. A few million years after the moon's disappearance, the chaotic gravitational tugs of the other planets have now had time to work on the Earth. Our planet's axial tilt has drifted from its comfortable 23.5 degrees to a new extreme angle of 45 degrees. What would our world look like? The analogy is a familiar house thermostat that has gone haywire. Instead of maintaining a comfortable temperature, it now swings violently between freezing and boiling. The house, our planet, would become uninhabitable. With a 45-degree tilt, the seasons would be amplified to an almost unimaginable degree. In the northern hemisphere's summer, the North Pole would be pointed much more directly at the sun than it is today. The Arctic would not just be a land of the midnight sun, it would be a blistering furnace. Temperatures could soar high enough to melt the polar ice caps in their entirety, raising sea levels by hundreds of feet and drowning coastal cities around the world. The temperate zones of North America, Europe, and Asia would experience summers of such ferocious heat that agriculture would be impossible, and much of the land would be rendered a barren desert. 6 months later, the situation would reverse. The northern hemisphere would be tilted far away from the sun, plunging it into a winter of deep, brutal cold. The ice sheets would return, advancing far south, covering vast swaths of the continents in glaciers thousands of feet thick. The difference between the seasons would not be a matter of gentle warming and cooling, but a catastrophic swing between a global greenhouse and a global ice age. Now, imagine the tilt swings the other way, towards 0 degrees. In this scenario, the Earth's axis would be perfectly upright. The sun would always be directly over the equator. There would be no seasons at all. The equator would become a zone of permanent blistering heat, while the poles would be locked in an eternal, ever-deepening winter, their ice caps growing year after year. The temperate zones between them would be locked in a perpetual, unchanging autumn or spring. This chaotic tumbling, this wild oscillation of the planet's tilt over millions of years, would make it almost impossible for complex land-based life to maintain a foothold. Evolution works on long, stable timescales. The constant, catastrophic resetting of the climate would prevent any species from truly adapting. An Earth without its lunar anchor would be a world of climatic whiplash, a planet hostile to the very idea of long-term stability. To truly understand why we have this precious stability, we must journey back to its violent, fiery birth. To fully comprehend the future of a world without a moon, we must first journey back in time, 4.5 billion years ago, to understand the past of the world that has one. Our moon is not just a rock we captured. It is not our sibling, born alongside us from the same cloud of gas and dust. The truth is far more spectacular. The moon is a child of the Earth, born from a planetary cataclysm of such violence. It defined the very nature of our world. This is the giant impact hypothesis, our leading scientific theory for the origin of the moon. The story begins with the young Earth, a molten, newly formed planet in a chaotic and crowded early solar system. It was not alone in its orbit. It had a traveling companion, a Mars-sized protoplanet that scientists have named Theia, after the Titan goddess who was the mother of the moon goddess, Selene. For millions of years, Earth and Theia shared a similar orbital path, locked in a gravitational dance, but the dance was destined to end in a collision. Theia, traveling at tens of thousands of miles per hour, struck the primordial Earth in a glancing blow. The energy released in this impact is almost beyond comprehension. It would be equivalent to the detonation of trillions of nuclear bombs. The collision was powerful enough to liquefy both worlds, turning the surface of the Earth into a global ocean of magma thousands of miles deep. The bituminal plume of vaporized rock and debris from both Theia's mantle and the Earth's mantle was blasted into orbit around our wounded planet. For a time, the Earth would have had a ring, a glowing, red-hot band of molten rock, far more spectacular than Saturn's rings of ice. Over the next few thousand years, the material in this ring began to clump together under its own gravity. It coalesced into a single, large, molten body. The moon was born. This violent birth is not just a dramatic story, it is the key to understanding our world. This impact is what gave the Earth its rapid initial spin. It is what tilted our planet to its initial 23.5 degrees. And it created a moon that was massive enough and close enough to act as the stabilizing anchor we have just discussed. The moon's composition, which is so similar to the Earth's mantle, is the key piece of evidence for this hypothesis. The exact details of this ancient cataclysm remain one of the great mysteries of planetary science. How large was Theia? How was its composition? How did the collision precisely shape the Earth-Moon system we see today? Our models are powerful, but the event itself is shrouded in the deep mists of geological time. To lose the moon, then, is not just to lose a satellite. It is to erase the evidence of the single most important event in our planet's history. It is to create a world that is unmoored, not just from its future stability, but from its own violent and spectacular past. The first and most immediate consequence of the moon's disappearance was the coming of a new, profound, and perpetual darkness. But this darkness was not an emptiness. it was an invitation. With the moon's powerful glare, a form of natural light pollution, gone forever, the night sky would reveal its true, breathtaking, and overwhelming nature. For most of humanity, living in our artificially lit cities, the true sky is a distant memory, a forgotten legend. We see a few hundred, perhaps a few thousand stars on a clear night. In a world without a moon, every night, for everyone on Earth, would be a spectacle that would rival the view from the most remote, high-altitude observatory. The analogy is of someone who has spent their entire life in a room with a single bright lamp on. They are aware of the world outside the window, but the glare from the lamp washes out all the details. The moment the moon vanishes is the moment that lamp is switched off. And for the first time, you can truly see the universe that has been waiting outside all along. The Milky Way would dominate the heavens. It would not be a faint, milky wisp, but a vast, blazing, and intricate structure of light and shadow, so brilliant it would cast faint, soft shadows on the ground. The great rift of dark dust lanes that runs through its center would be a stark, dramatic river of blackness, weaving through a field of billions of points of light. The galactic core, in the direction of the constellation Sagittarius, would glow with an intensity that would become a new focal point for human attention. The number of stars visible to the naked eye would leap from a few thousand to tens of thousands. The sky would appear thick with stars, a dense, glittering tapestry that would stretch from horizon to horizon. Faint, fuzzy objects that were once the exclusive domain of astronomers would become common sights. The Andromeda Galaxy would be an obvious, luminous smudge. The great nebulae of Orion and Carina would be visible as faint, ethereal clouds of pink and gray. And the shooting stars, the meteors, would be a constant presence, with no moonlight to wash them out. Even the faintest trails of cosmic dust burning up in our atmosphere would be visible. Meteor showers like the Perseids or the Geminids would be transformed from a pleasant celestial event into a breathtaking, sky-filling display of silent, cosmic fireworks, with hundreds of streaks of light painting the sky every hour. This new, staggeringly beautiful sky would have a profound effect on our species. Would we have developed astronomy far earlier? Would our mythologies, born under a sky dominated by a single personal moon, have instead been shaped by the overwhelming impersonal scale of the galaxy? It's a deep and unanswerable question. The loss of the moon would steal our closest companion, but in its place, it would give us a raw, unfiltered, and terrifyingly beautiful view of the infinite. Amid the chaos of the changing tides and the slow unbalancing of our world, the disappearance of the moon would mean the permanent loss of one of the most sublime, awe-inspiring, and scientifically crucial events in the natural world: a total solar eclipse. A total solar eclipse is the result of a spectacular and improbable cosmic coincidence. The sun is approximately 400 times wider than our moon, but the sun is also, by a cosmic fluke, approximately 400 times farther away. This perfect ratio of size and distance means that from our vantage point on Earth, the tiny moon and the colossal sun appear to be the exact same size in the sky. This allows the moon to act as a perfect occulting disk, a celestial shield that can, for a few precious minutes, slide directly in front of the sun and block its brilliant face from view. To stand in the path of totality is to witness the sky break as the final sliver of the sun disappears behind the moon. The world is plunged into an eerie, otherworldly twilight. The temperature drops, the wind stills, animals fall silent, and where the sun once was, a new and impossible object appears, a black, empty hole in the sky, surrounded by the ethereal, ghostly white flames of the sun's corona. The corona is the sun's outer atmosphere, a halo of plasma heated to millions of degrees. It is always there, but it is a billion times fainter than the sun's surface, making it completely invisible under normal circumstances. An eclipse is the only time we can see it from Earth with the naked eye. It is a glimpse into the secret, violent heart of our star's atmosphere. The analogy is a single, perfectly sized key that fits a cosmic lock. For a few brief moments, this key turns, the door swings open, and we are allowed to see one of the universe's most carefully guarded secrets. With the moon gone, this key is lost forever. Humanity would never again witness the sun's hidden crown. We would lose not just a beautiful spectacle, but a vital scientific tool. Eclipses have been crucial to the history of science. It was during an eclipse in 1919 that astronomers were able to observe the light from distant stars bending as it passed by the sun, providing the first observational proof of Albert Einstein's theory of general relativity. Eclipses allowed us to first discover helium and to study the composition and dynamics of the sun's corona in ways that are still difficult to replicate, even with our most advanced spacecraft. The loss of the eclipse would be a permanent closure of this natural laboratory. We would be locked out, forever unable to see the sun's magnificent ghost. It is a subtle loss compared to the drowning of coastlines or the chaos of the climate, but it is a profound one. We would lose the one moment where the clockwork of the cosmos aligns in perfect, breathtaking synchronicity to reveal a hidden truth. The sky would be forever robbed of its greatest magic trick. Beyond the physical transformation of our planet, the disappearance of the moon would inflict a different kind of wound, a deep and permanent scar on the human psyche. For as long as we have been human, we have had a relationship with the moon. It is woven into the very fabric of our cultures, our languages, our myths, and our dreams. To lose it would be to lose a fundamental part of ourselves. The moon was our first clock. Its steady, predictable cycle of phases from new to full and back again gave us our first unit of time beyond the day, the month. The word month and the word moon itself are ancient siblings born from the same linguistic root. Our first calendars, from the ancient Babylonians to the early Romans, were lunar. We planted our crops and timed our festivals by its phases. It was the first celestial rhythm we learned to read. It was also our first god. In countless ancient cultures, the moon was a powerful deity, a goddess of the night, of the hunt, of magic and mystery. It was a symbol of femininity, of cyclical change, of birth, death, and rebirth. It was an object of worship, a silent, knowing face that looked down upon the world and guarded its secrets. Even as science stripped it of its divinity, the moon retained its power over our imagination. It became a symbol in our art and literature. It stood for romance, for madness, for loneliness, for longing. The word lunatic is a relic of a time when we believed the moon's light could drive people insane. Our stories are filled with creatures, like werewolves, whose transformations are governed by its light. It has been a constant source of metaphor, a shared cultural touchstone for all of humanity. The analogy is erasing a single fundamental word from every language on Earth. Imagine a world with no word for water. We could still describe it, but something essential would be lost. The concepts, the stories, the feelings associated with that single word would become fractured and disjointed. The moon is that word for our collective cultural story. Its disappearance would leave a gaping hole in our shared consciousness. Our nights would be darker, but our myths would be poorer. Our poetry would be emptier. We would look up at a night sky that was scientifically more brilliant. But culturally, emotionally, it would be a desolate void. The silent, constant companion that has listened to the stories of every human who has ever lived would be gone. And with it, a part of what it means to be human would be lost forever. In the millennia following the disappearance of its great guardian, the Earth would be a lonely, tumbling world. Its climate would be racked by chaotic seasons, its oceans stirred only by the faint pull of the distant sun. Would it be destined to this solitary fate forever? Or could the Earth, in its long journey through the cosmos, find a new companion, capture a new moon to take the place of the old one? The process of capturing a moon is an event of incredible gravitational delicacy. It is not as simple as an object wandering too close and getting caught. An object approaching a planet from deep space has too much energy. It will swing by on a hyperbolic path and fling itself back out into the solar system, destined to continue its journey. To be captured, it needs to be slowed down. It needs a break. The analogy is trying to catch a speeding bullet with your bare hands, and direct catch is impossible. It will simply pass through. You need a way to absorb its energy, to slow it down enough to hold on to it. In the solar system, there are a few ways to apply this cosmic break. One way is through an atmosphere. If a passing asteroid or comet were to clip the top of Earth's atmosphere, the atmospheric drag could slow it down just enough to be captured into a long elliptical orbit. This is how many scientists believe Mars captured its tiny moons, Phobos and Deimos. However, this method only works for relatively small objects. A large object, one massive enough to have a stabilizing effect on the Earth, would likely be torn apart by gravity or cause a devastating impact event, rather than settling into a stable orbit. Another way is through a complex, three-body interaction. Imagine an asteroid and its own small moonlet are flying by the Earth. If the timing is just right, the Earth's gravity could capture the asteroid and simultaneously eject its smaller moonlet, carrying away the excess orbital energy. This is a rare cosmic billiard shot of immense precision. So while it is theoretically possible that the Earth could capture a new moon, the chances of it capturing one that is large enough to replicate the stabilizing effect of our lost companion are virtually zero. Our moon is a freak of nature, representing over 1% of the Earth's own mass. No other moon in the solar system comes close to this ratio with its parent planet. It is simply too large to have been captured. The Earth might, over millions of years, sweep up a few small asteroids, which would appear as tiny, fast-moving points of light in our night sky. But they would be no replacement. They would be tiny, gravitationally insignificant companions, unable to raise meaningful tides, unable to hold our planet's axis steady. They would be celestial pets, not guardians. The verdict of orbital mechanics is clear. The loss would be permanent. The stability, the tides, the eclipses, the cultural significance, all of it was the result of a single massive moon born from the unique violence of our planet's past. You cannot replace a child of the Earth with a wandering stranger. The Earth, once unmoored, would be destined to drift alone. We began our journey by imagining a single impossible event, the vanishing of the moon. We plunged our world into darkness, only to reveal the breathtaking brilliance of a billion distant stars. We stilled the great breath of the oceans, and in doing so, triggered the slow collapse of our coastal ecosystems and the unraveling of our climate. We unmoored our planet from its celestial anchor, setting it on a long, chaotic path towards a future of wild, uninhabitable seasons. We have seen that the moon is not just a companion, it is a creator, a stabilizer, and a historian. Its disappearance reveals a truth that is as profound as it is unexpected. For all of its beauty and all of its cultural power, the moon's greatest gift to the Earth was not its light in the darkness. Its greatest gift was the stability it provided for life to flourish in the brilliant, life-giving light of the sun. The moon is the reason we have a stable 24-hour day. It is the reason we have gentle, predictable seasons. It is the reason we have the dynamic, nutrient-rich oceans that allowed life to crawl onto the land. It is the silent, gravitational partner that took a chaotic, tumbling young Earth and tamed it, transforming it into the steady, reliable, and habitable world we know today. The analogy is that of a ship's keel. It is a part of the ship that is unseen, deep underwater, but it is the source of all the ship's stability. Without it, the ship would capsize in the first major storm. The moon is the keel of Starship Earth. To imagine a world without it is to truly and for the first time appreciate the world we have. It forces us to see the moon not as a separate entity, a beautiful object over there, but as a fundamental component of our system, as integral to the workings of our planet as the oceans, the atmosphere, and the ground beneath our feet. Our journey into this hypothetical world leaves us with a sense of profound awe for the delicate, improbable, and violent chain of events that led to our existence, and for the silent, steadfast guardian that made it all possible.